Given a line of n people with distinct positive heights. Each person looks to the right. Person I sees person J if everyone strictly between them is shorter than both endpoints. Return an array where entry I counts how many people to the right person I can see. Constraints, n up to 100,000, heights up to 100,000, all distinct. Example 1, heights 10, 6, 8, 5, 11, 9. Focus on index 0 with height 10. They see height 6 immediately to the right. They also see height 8, because the 6 in between is shorter than 8. They cannot see 5 across the 8. They do see 11 at index 4, with everyone in between under 10. They do not see 9 past the 11. So the first answer is 3. The full output array is 3, 1, 2, 1, 1, 0. Example 2, heights 5, 1, 2, 3, 10. The leftmost height 5 sees all 4 people to the right. The answer array is 4, 1, 1, 1, 0. We keep this single row for the whole scene, indices 0 through 4, height 6, 4, 7, 2, 5. Right to left, look at index 4 first. Its height is 5, so the stack holds only 5. Step to index 3. Height 2 stacks on top of 5, bottom is older, top is closer to us. Different point, index 3 and index 4 are next to each other, nobody stands between. That pair always gives one clear sight line. Back to index 2, height 7. After processing 4 and 3, the stack from the right still reads 5 then 2, same 2 chips we just built. 7 beats the top of the stack, 2 is shorter, so pop 2, that is one counted site in this model. 5 is still shorter than 7, pop 5. Stack is empty, then push 7. That walk was the real algorithm in miniature. Scanning right to left, add 1 to the answer for every shorter height you pop, each kick off the stack is one more person counted. If someone taller is still there after those pops, add 1 more, that is the next person who blocks your view. Then push your height. The neighbor you always notice first is folded into that same rule, no one between 2 positions means those sites show up as pops or as that extra +1 toward a taller blocker. This is the usual monotone stack, heights on the stack stay in non-increasing order as you move left. We walk indices from n-1 down to 0. The answer array starts at all zeros. The monotone stack stores heights already processed to the right, the skyline you compare against. Start at index 5, height 9. Nobody stands to the right, so the count there stays 0. Push 9, the first value on the stack. Index 4 is 11. 9 on the stack is shorter, so pop it and add 1 to the count at 4. 9 is gone for good for anyone farther left. Push 11. Index 3 is 5. 5 does not clear 11, so no pop. The stack top is still 11, add 1 for seeing that taller neighbor, then push 5. Index 2 is height 8. 5 on top of the stack is shorter, so we pop 5 and add 1 to the answer at index 2, first increment. 5 is gone, only 11 remains for now. 8 is still below 11. That is a second sight line, add 1 more at index 2. Then push 8 onto the stack. Index 1 is 6. It does not pop 8, so take 1 for the stack top 8, then push 6. Index 0 is 10. Pop 6 and 8, 2 increments, then add 1 for 11, and push 10. The answer row reads 3, 1, 2, 1, 1, 0. Each index enters the stack once and leaves at most once, so the whole pass is linear time and linear stack space. That matches the counts we just filled in. Let n be the length of heights. Time is order n in the worst case, each person is pushed once and popped at most once, and each stack step is constant time. The stack is monotone, heights from bottom to top never increase while we scan from right to left. Space is order n for that stack when many tall people remain. The answer array is part of the output, not extra auxiliary tricks here. Pseudocode for visible people in a queue. Function canCPersonsCount takes the height array. Let n be the length of heights. Build an answer array of n zeros. Start with an empty stack list. Loop I from n-1 down to 0, scanning right to left. While the stack has a top height strictly less than heights at I, we keep popping. Each pop adds 1 to ans at I. Remove the top of the stack. If anything remains on the stack, there is a taller wall to the right. Add 1 more to ans at I for that blocking neighbor. Push the current height onto the stack. After the loop, return the answer array.